Good morning, everyone. Myself, Monica Nansupriya, Assistant Professor in the Department of Electrical and Electronics Engineering. In this semester, I'm handling W3017 Embedded C Programming in the Regulation 2021. Today, we are going to discuss two important concepts in Embedded C Programming, that is hardware delays and timeout mechanism. As we know, in the embedded system, we are not just writing programs, we are controlling hardware devices like LCDs, sensors, motors. This hardware does not respond instantly. It needs some time. That is where the delay and timeout concepts come into the picture. So we have discussed today what are the topics we are going to discuss is why delays are needed, types of delay method, what is timeout, why timeout is very important in real systems. These are the topics we are going to discuss. And the introduction to the hardware delay is the embedded systems interact with hardware devices. For example, when we send command to the LCD, it needs time to display. When we power a sensor, it needs stabilization time. In communication protocol, there is a specific timing is required. If we don't give proper delay, the hardware may behave incorrectly and the system will get collapsed, and the compiler also doesn't give alert or doesn't give errors for this, but it executes, and for that the hardware may behave incorrectly and the system will get collapsed. So the hardware delay ensures a proper timing between the operations. For example, when you switch on a fan, it doesn't rotate at full speed instantly. Now similarly, the hardware components need some time gaps. So without a time gap, there is a without a time gap, the fan will rotate fastly. Then what is the hardware delay? A hardware delay is simply a pause in the program execution. During this pause, what happens? The CPU waits, the hardware completes its operation, and it always usually measured in microseconds and milliseconds. And we have there are two ways to generate delay. What are the delays? Software loop and hardware timers. In this, which method is more accurate? Would you know about which the method is more accurate? We have a hardware timers. If we set the alarm in your phone, what it happens? It is a hardware timer. So the when the alarm will get ringing when which time you are giving, no, that time the alarm rings. Okay. Then the next one is the software delay. In this method, we use empty loops to create delay. We just use the empty loops. This is the empty loop for in type. We are doing in a lab experiment for the blinking of LED or flashing of LED. We have initiate this for loop within the condition. Because of this is the delay time, the LED will blink with the delay. So here the CPU just count the numbers and waste time. So the CPU remains busy and it is not accurate, depends on the clock frequency. If clock frequency changes, the delay also changes. So this method is simple but not suitable for the real-time systems. Then the hardware timer based delay. This method use the internal microcontroller timers. This microcontrollers like 8051 have built-in timers also. So instead of wasting CPU, we configure timer register. We set the timer register and wait for the overflow flag. How the overflow flag will get on time and generate the accurate delay. So if we generate the accurate delay, then the system will get more accurate and suitable for the real-time application for the professional method. So in the industry, the hardware timers are only preferred if in case some requirements may initiate the software delay, so that that the efficiency must be low compared to the hardware timers. Next one is the timer delay in embedded C. Here the example for the void delay MS. What is mean by MS? We are having the while MS. What is mean by MS? Here the MS is the delay value. What is the value are giving in the place of MS? So MS, how much time you get into the delay time, how long you get into the delay time. This will shows the MS. So this program, the timer is configured, the MS is the delay value. So timer registers may be configured properly. The next one is the we wait for the overflow flag. Is that the timer register may be configured properly, otherwise the delay will be wrong. Then the application is have a separate example for a LED blinking without delay. The LED will blink too fast, so we can't notice that if the LED is blinking or not. If we have the delay timers much higher, then we should see the appropriate changes in the LED blinking. So the LED will get off and the LED will get on so that the LED blinking is we can see in our real time. So next one is the LCD command execution. It needs a delay after each command and it's a UART communication, proper timing between the data transmission. Next one is the PWM signal generation. The pulse width depends on the delay timing, how much the delay timing should be. So the pulse width generation will takes place and the task scheduling depends on the timing, whereas in the real-time operating system. As of now, I told no that the alarm which is set into the phone that is by the real-time operating system, that is RTOs. Then the advantages and disadvantages is it is simple implementation and essential, very necessary for hardware control. The disadvantages software delay, waste the CPU time, and incorrect timing may affect the system performance. The incorrect delay affects the system, so the efficiency will get low. If delay is too small, the LCD may show the garbage data. So these are the disadvantage which is in the hardware delay. Next one is the timeout mechanism. The timeout is the maximum waiting time. If expected event does not happen within the time, the systems exist safely. If we don't give the timeout, the system will get freeze. We must give the timeout for the, such a response. If you are calling one person and the call after some rings, you cut the call or it may cut the cut it may cut it by the that corporation that or that signal the signal maker, that is the timeout. If you are calling one person, he is not attending, he she are not attending, then the call will go and go and go. What will happen? The system will get freeze. So the timeout is very important and it is used in the communication mainly and it's used for the hardware interfacing. Why the timeout is needed? It prevents the system hanging. Oh, as I told, no, someone you call, no, then the ring will go and go and go, so that the system will get freeze, the system will get hanging. So the avoids the infinite loop. At the time someone called you, then it will get busy tone. So this will avoid the infinite loops and the handles hardware failure. What it means, you are calling, if the person will not attend, it's a ringing is going, the ring is going, and it was then it heats the hardware gets heat, so it leads to the hardware failure, and these are the things why the timeout is needed. This is essential in real-time system. If we don't use the timeout, the system may freeze. Next is the example without the timeout. Here the UART flag never sets, the system waits forever. The flag will check, this causes the system lockup. If the UART flag is not set, if this loop wait until UART flag becomes 1. If flag never becomes 1, the system waits forever. This is called the system called the lockup. Is this safe in industrial systems? Yeah, no. We have a timeout for the uh, perfect efficiency or perfect conditioning, perfect running condition. So the timeout is very important. And the example with timeout, int timeout is equals to 10,000, while UART flag at timeout. Here they are mentioning the timeout. If timeout is equal to 0, then the system exists safely if there is no response. The timeout counter is initialized. Here we are initializing the timeout counter. So the loop checks both the condition where the timeout the flag is set, the flag is not set. If the flag is not set, the counter becomes 0 and it exits. So the system safe and the error will be handled. So the professional coding practice will maybe appear. Next one is the timeout using the hardware timer. Instead of software counter, we use the hardware timer. The steps are first you have to configure the timer, then you start the timer when the waiting begins. Wait for the event. If the timer expires, they generate the interrupt. If the timer will get expire, if you called one person, 1 minute it will be ringing. After that 1 minute, then it generate the interrupt. Now, then it comes to the home page or the system will get remains constant. So it becomes more accurate and used in the advanced systems. And applications of timeout mechanism is the UART communication, I2C, SPI data transfer, sensor reading, network communication, watchdog system. If the system hangs, the watchdog resets microcontroller. So it is very important concept in the industry. And to summarize this, the hardware delay is necessary for proper hardware control. The software delay is simple but inaccurate, and the hardware timer delay is more accurate. And the timeout mechanism prevents the system hanging. And the timeout is mandatory in communication routines. In embedded system, timing is very important, and the hardware delay is also very important, and the timeout process is also very important. So we have discussed these topics in this session. These are the references. And thank you for watching this video.